All right, so let's do question 6. All right. So question 6. Hydrogen gas reacts with iodine gas to form hydrogen iodide according to the following equation. H2 plus I2 forms 2HI at 700 K. At equilibrium, the concentrations for hydrogen, iodine, and hydrogen iodide are as follows: 0.214 moles per liter, 0.214 moles per liter, and 1.57 moles per liter respectively. What is the value of the equilibrium constant for this reaction? So the relevant dot points, the relevant syllabus dot points, so we're calculating the equilibrium constant. So this is the third inquiry question of module 5. Students deduce the equilibrium expression in terms of KEQ for homogeneous reactions occurring in solution. So again, not in solution, but it is a homogeneous reaction. And then perform calculations to find the value of the equilibrium constant and concentrations of substances within an equilibrium system, and use these values to make predictions on the direction in which a reaction may proceed. Okay, so we don't need this part of this dot point. You use these values to make predictions on the direction in which a reaction may proceed, because we already know that the system is at equilibrium. So we're not calculating the reaction quotient, we're calculating KEQ. The equilibrium has already been reached, so the reaction won't proceed in any direction. The question already tells us this is at equilibrium. So we will be calculating the equilibrium constant, not Q, not the reaction quotient, KEQ. The difference between the reaction quotient and KEQ is that the reaction quotient represents where is the equilibrium right now, and KEQ represents what is so Q, the reaction quotient, represents what is the ratio of products to reactants right now, right? And then KEQ represents what is the ratio, what is the equilibrium ratio of products to reactants. So I guess K you could think of as the ideal ratio at a specific temperature. It is also the ratio that a system will try to move towards. That's what it means by predictions on the direction in which a reaction may proceed. So if the ratio isn't the equilibrium ratio or the KEQ ratio, then the reaction will proceed in a direction. Sorry, this is a lot of background, I guess, not strictly needed for this question. We already know that this is at equilibrium, so we're calculating KEQ. And then we can write the equilibrium expression, the ratio of products to reactants, iodine, hydrogen, and then we weight them by the stoichiometric ratios. We raise it to the power. We raise hydrogen iodide to the power. These guys are to the power of 1, so we don't need to write that down, but let me just write that down so you can see. And then what is the value of the equilibrium constant? So we just need to sub in these concentrations into this equation to find KEQ. So let's do that. KEQ will equal respectively 1.57 squared divided by 0.214 times 0.214, right? I just subbed in these values, the concentrations for hydrogen iodine and hydrogen iodide, into the equilibrium expression. So let's see what this evaluates to. .57 squared divided by 0.214 times 0.214. That comes out to 53.82. That would be, so the answer would be D. And if we scroll down, we can see that the answer is in fact D. Trying to think, is there anything that might trip up a student in this question? I don't think so. So seems like a simple question. What is the value of the equilibrium constant? We know that it's at equilibrium. As long as you sub in the values correctly, as long as you know how to write the equilibrium expression, which in itself is not too difficult, and then you sub in the values correctly, that should be an easy mark.